we're doing the same thing. This time we have a slightly more complicated looking integral, but remember for trig substitution we're really only focusing on one part of the integrand. So in this case, we need to be looking here at this 4 minus x squared. Remember that whenever you have a number plus or minus a variable squared, or the variable squared plus or minus a number, that's the setup for a trig substitution. And we just need to figure out which trig substitution are we going to do. So when we have numbers minus variable squared, we want to use sign, and that's because we know that this identity holds. So this is just a rearrangement of sine squared plus cosine squared equals 1. So we have 1 minus sine squared equals cosine squared, so if x had to do with sine squared, and we could get the coefficients to match up, this would work out perfectly as a trig substitution. So we know that x has to be something to do with sine theta, but remember that we need the coefficients to match in order to get rid of, in order to have this factor in there. So this needs to be 4 sine squared theta, so that we can factor out the 4, and we get 1 minus sine squared theta. So if when you square it, it has to be 4 sine squared theta, that means you had to have started with 2 sine theta, so that the coefficients match up, and you're able to do your trig substitution. So for that one, remember, just look at how the numbers and the variable squared are aligned, and that'll tell you which trig substitution to use.